Dr. Corrington quickly joined into that research project as well. And then because all of you are so wonderful, we're so willing and able to accept Caitlin into our little small working group here. And that has just grown to now the audience that we have in front of us today. So I just can't thank all of you enough for embracing Caitlin and her research interests. So I thought we'd start with going around doing some introductions. And I served as Caitlin's honors thesis advisor. And Dr. Corrington was her honors thesis reader. So we were her main points of contact throughout this process. But I'd love to start with Dr. Dobbins, just telling us your role that you play in Amgen and connecting to this project. And we'll just go around, kind of tag each other from there until we get back to Caitlin.
Well, I'm Dr. Joanne Dobbins, and informally, I'm just Joey. So I'm director of the ABE Kentucky group. And as such, my role is to help facilitate in any capacity at Bellarmine what ABE might do from there. And just as a side note, I had Caitlin as a student. So that's nice. That was a nice follow up of what she did last time I saw her. We had the privilege of having her with one of our community outreach programs, the Kappa League, and she did an excellent job at that venture. So we love including our students. So Tyler, why don't you introduce yourself next?
Sure. I'm Tyler. I feel like I've met with each of you all at least once. I'm the site coordinator and technician for ABE Kentucky. And sorry if I sound a little bit under the weather. I'm a little bit under the weather. But I worked with Caitlin a little bit, helping her prep stuff and co-running some of these events that we do. She's a lot of fun. I think the kids like what she does a lot. So I'm looking forward to working with her a little bit more.
Who's next?
Diane, why don't you go next?
Sure. I'm Dr. Diane Corrington. My role with ABE is an ambassador and community STEM liaison, which I don't know if that name will change this year, but here we are. So I do some work around equity and access and building community partnerships with the ABE. But at Bellarmine, I'm a faculty member in the School of Ed. And so glad to have Caitlin, who is a natural educator. So it's been a joy. Tara.
Sure. Thanks, Dr. Diane. So I know all of you, but Tara Bristow, and I consult for the program office for their implementation team. And I was just really excited when I got to meet Caitlin. And, my role was really to connect her to the resources that have been developed by the program office, especially those that one of my colleagues, Libby, had been working on. And so just, kind of pointing her in the right direction of that and some other resources. And I'm just excited to hear what came out of all of that. So Jess.
Hi, everybody. I'm Jessica Juliuson. I've met some, but not all of you, and I'm the Director of Community and Strategy for the ABE Program Office. And I am not a technician, but I am really excited at the chance to kind of hear about these new resources being developed and be thinking about how we might be able to share those across our community, which is international. And we know we have lots of program sites who will be interested in learning more about this. So I'm very excited to hear more about this project. Rebecca?
Well, thank you. Caitlin, it's a pleasure to meet you. I think I've met most everyone else. I am the director of the ABE Program Office, overseeing the global 27 sites that we're now up to. Hoping to get to 28 shortly. And we've been supporting the ABE program since 2011. We've been working with the Amgen Foundation, but established the program office in 2013 and have been really excited to see the program not only grow in terms of locations, but in terms of the kinds of experiences that our sites are thinking about. So this is just a really wonderful dovetail to some of that expansion that we've seen really being driven by the needs that our sites are seeing from their teachers and students. So really excited to hear from you and to hear more about what you've been doing. And I'll turn it over to Christina.
All right, thank you. I am Christina Hahn. I am the site coordinator and technician for the ABE Canada site. So basically Tyler's counterpart at ABE Canada. I also serve as one of 2 master lab technicians that support the global program office, and ABE Kentucky is under my umbrella. So I've been working with the team for the last 4 years now.
2 years.
2 years? Oh gosh. And Caitlin, you and I had sort of connected back and forth about your presentation as well, and very much similar to both Rebecca and Jess and Tara. Just really interested in hearing what you've been able to do and your project in the classroom, and possibly modifying some of that to our classrooms here.
That's wonderful.
Okay, guess that turns it over to me. So, hi everyone, I'm Caitlin, and like Dr. Cook said, I'm a senior biology major here at Bellarmine, and yeah, so I basically came into doing my thesis, and I have a presentation, so I'm going to start pulling that up as I kind of start talking. I came into my thesis, and as a biology major, I really do love science, but I didn't want to be strictly like within like a lab setting because I don't know, I just felt like there was more that I could do with it. So that is kind of how I found like education and went like the education route. Let's see. Let's see. Can y'all see that okay?
Yes.
Okay. Let me see if this will do it like that. Okay. So the title of my thesis is Promoting Engagement Through Socioscientific Inquiry at the Middle School Level. And yeah, I'm good. Like Dr. Cook said, she was my advisor and Dr. Currington was my reader. And they were a really big support throughout all of this process. So like I said, I kind of wanted to do something different than just like lab based. And so I thought, how can we make learning science more fun? Because, typical science instruction is, lecture, a teacher stands up at the front of the class and kind of just like teaches you this. You read a textbook and you answer some questions. But it wasn't until I got to college that I started to see that it's much more than just learning about the facts. It's like a process and the way of looking at the world, and that society greatly influences how we view science and what comes out of science. So I thought maybe the way science is taught in our schools should reflect this, and that maybe we can find a way to update the curriculum or improve it. And so another kind of main reason why I did middle school was that's when I personally started to think about my future and like the connections to the real world. Like, why am I learning this science? Why is it important? How do I make those connections? And like I said, it wasn't until I reached higher grade level college that I started to make those like applications of science, especially within like the social and like ethical realms of it. So my question was, had this been introduced earlier in my education, would it have impacted my view of science and learning? So over the past couple of years, research has shown that there has been an increase in like student drop off in science. And so because their perception of it isn't what it should be, there's like a miscommunication. They're not exactly sure how science plays out in the real world. They just think of like somebody in a lab coat. So maybe we could like change that. And so kind of like as some more background info, Kentucky currently uses the next generation science standards, and that's like a 3-dimensional framework. And basically you combine the science and engineering practices, which is like your investigation, building models, and then you have your disciplinary core ideas, which are like your most important aspects of science. So that's like biology, chemistry, physics, the big ones. And then we have cross-cutting concepts, which are like the linking applications between all of those, so like cause and effect, systems, energy, stuff like that. And I really did like this diagram because it kind of shows that we're starting to move towards finding all those like different connections between science and all that. And Kentucky implemented the next generation science standards in 2013. So middle school students in science, like I said, there is like a false and unclear perception of like what science has to offer them or what they do. And so with that, their perception of science directly influences their engagement with it. And their engagement is kind of like a three-dimension like construct almost. So we have behavioral engagement, which is like the actions students take towards their school and learning, whether they're actively doing their work in class, participating in discussions, stuff like that. And then we have emotional, which is their sense of identification with their school and their learning. Like, do they like what they learn? Do they not like what they learn? Like, do they have any reaction towards it? And then we have cognitive engagement, which is the self-regulated and strategic approach to learning. So that's more of the like critical thinking skills, really what education within science is like trying to push, like development of those like important life skills almost. And so here's another really nice diagram that kind of shows that this is all like dynamically interrelated within an individual and within a student, and they're not individual processes. So we kind of have to look at all of this when we're looking at student engagement. So that brings me to socioscientific issues, which was introduced to me by Dr. Cook because she had done previous like research on it and kind of like introduced me to this topic because it kind of went along with what I was looking for with my project. And so SSI are complex issues with ties to science and society, which create dilemmas and are prone to multiple solutions. So you have an idea or a topic that is based in science content, and then you have the thoughtful consideration of the issues like social, economic, political, and ethical aspects in the world. And so this diagram right here kind of shows the current like learning framework for SSI. So you kind of start with a focal issue, whether some students interact with it in media or in a book they read or an article. So that's like where you start. And then you develop it based off of the science ideas and practices. And then you start to tie in that social aspect of it. And then you end with like a synthesizing, like accumulating activity that kind of ties them both together. And the main thing about SSI is that science alone cannot solve these issues. And so with this, students can start to see how science impacts their everyday life and their societal decisions. Also, it allows students to see different perspectives and start respecting them because you're going to have interesting conversations when it comes to controversial issues. And so that's just another route to help build their thinking and problem solving to, potentially address these issues and have those conversations. So real quick, the benefits of that SSI is that you're focusing on that science content and practices, you're working on your problem solving, you're increasing interest and motivation in science, and then once again, you're building those reasoning and critical thinking skills because they're kind of developing their science-related awareness and personal growth within science. Although there are some challenges. So it is a relatively new and unfamiliar format to teachers, so there might not be inclined to implement it within their classroom. Also, there is some time constraints because you have to find a way to work it in, and it's not only like finding the time within all the stuff that they have to teach within the school year, trying to like fit in these lessons, it can be quite difficult. And then because you're going to deal with like emotional or controversial issues, some teachers might not feel adequately like equipped or unsure how to deal with students if they have strong emotions towards these topics. And then another big one is resources and professional development are really needed for SSI to work. But luckily, there's ABE, which is an amazing program. I'm sure you all know so much about it. And so with ABE, you are having that program that their main bread and butter is to help students become more engaged in learning science with the curriculum, the tools, and the techniques. And you all are offering resources to these teachers just go on your website and there's so much stuff. It was like so exciting to explore all the stuff that there was. And I really liked how teachers have the ability to loan out that research grade equipment and basically turn their classrooms into an advanced science lab, because that way you're kind of bringing science in the real world into the classroom. And so students can actually see with their hands what they're doing and how it's making an impact. And so I found this little quote from the ABE's website that it directly aligns with the National Research Council's finding in high quality laboratory experience promotes students' interest in science and science careers. So yeah, it all kind of like tied together, and I'm so glad I found ABE. So the specific topic that I focused on in the lesson that I did with the middle schoolers was gene editing. And so with this, I kind of went off the designer babies lesson that ABE has. And so basically the learning goals were to kind of teach them about gene editing, the potential benefits and risks of it, and then have them like make or defend an argument about whether or not we should use it in society. And then, with CRISPR, it is a controversial issue because you have like the ethical and safety concerns, and it has been banned in certain countries. So that's probably why it's such a controversial topic. So real quick, my research questions for my thesis were, how can the use of SSI within science curriculum impact student engagement? How can students use their SSI learning to apply their understanding in a social context? And in what ways do students and teachers perceive and experience SSI? Like I really wanted to target what the students were getting out of it. So my participants. So I went to a local suburban middle school in the greater Louisville area, and I focused, due to personal time constraints and time constraints for the participating teacher, I could only do one of her classes. So it was a group of 26 middle school, 7th grade students and their teacher, Miss Holovinka. So basically my study design was, I was going to do the designing babies with CRISPR lesson and then combine it with day 1 and day 2 of the tools of the trade biotech experience. And then my accumulating activity was a discussion diamond on gene editing. And the way we modified it, we fit it into 2 days. And I did have to make some modifications with the teacher, and then also with Dr. Cook, we kind of talked about it because the ABE lessons were mostly targeted to high school level. And we didn't have to make too many adjustments, just kind of like assess what the middle schoolers already previously knew about genes and editing, which wasn't too much. So we kind of like went down to the basics of it. And so they did like lab-based applications, collaborative discussions, reflective writing, and basically using, the pipettes and the gels and all that good stuff. So here are some pictures of the PowerPoint that I made. So we kind of, like I said, we did the basics of like, what is gene editing? We talked about CRISPR. I gave them an example of gene editing, especially within like the medical field, and talking about like cancer cells and finding a way to treat that. And then also we started to do pipetting on day 1. And then day 2, we really focused on doing the gels, seeing the DNA, practicing those skills more and more. And then for like the discussion aspect, to talk about, is gene editing acceptable, to really target that like SSI, the controversial part of it, I kind of started out by talking about like Frankenstein, which actually I think Tara kind of showed me a study that kind of like used that to kind of like guide the lesson for, I think it was elementary school students, but it actually went over really well. Because once I talked about like, oh, what was the public's view of like Frankenstein between like the scientist and the monster, that's when like the questions started forming. And then on the bottom right is just a picture of that discussion diamond. So each student got a corner where they did their personal thoughts, and then they came together as a table to kind of have like collective thoughts, and then we shared as a class. And so real quick, for data collection purposes, I did questionnaires for the students before and after the SSI instruction. I did interviews with the teacher pre and post, and then I collected classroom artifacts. So I collected those discussion diamonds, and I collected all the questions that the students had, because as soon as I introduced the tools and the topic, they just exploded with all of these questions. So I basically gave them all pieces of paper, and I was like, y'all write whatever you want and we will talk about it. And then also I had the privilege of actually being there for both of those days. So I actually got to experience it firsthand. So I had those sit-in observations. So kind of get into the results. These were their initial perceptions of science. So I had a whole list of like questions about like, oh, what do you think of science? Do you like science? Do you participate in class? And it basically, the students showed that there's an interest in learning science and they understood the value of it, of learning it within schools, but some were still unsure of the connections. So although we had 41% that agreed that they see the connections science has in the social realms, you still had other students that either strongly disagreed or just weren't sure at all. And then for the I apply what I learn in science with my everyday life, you can see like there's a wide variety of answers. And then one of the other questions I asked was, do you want to be challenged when you learn science? Or do you want to learn more difficult science concepts and about the uses in the real world? And most of the students agreed with those statements. So this is the ABE lab equipment that we used. And I would just like to say the students were so excited about it and they were very successful in using that stuff. They picked it up so unbelievably quick. They motivated each other, they were encouraging each other. They didn't really, there was a concern that they might, I don't know, accidentally break a pipette or not use it right, but everybody was respectful with the tools and were really just like excited to like do it and work with their hands. And they really liked seeing the gels and doing all that because I had them do the silicone practice gels and then I ran an actual blue gel and they thought that was like the coolest thing ever because they're like, oh, it's like Jello, all that stuff. But yeah, they really loved it. And so this little table kind of shows some of the questions that the students were asking. So we had like social application questions like, oh, could gene editing be used for cosmetic purposes or negative power? Or like, how would insurance pay for it? And then you have the science ones where it's like, oh, curing diseases. Someone asked about like donating DNA or donating blood or like adapting to new environments. And then we had more content-based questions, which was like, who invented CRISPR, who came up with it, more questions about DNA. And then, of course, you're always going to have some questions from middle schoolers that are like, oh, can we bring back dinosaurs? Can I grow a tail? Can I make a green baby? Just kind of just like out of the box thinking, which I kind of expected going in, but it was exciting to see like where their brains went with it. And with these, it kind of shows that they were using their reasoning and critical thinking skills, applying their learning. And then these questions kind of showed that there was an increased interest and motivation to learn more about the topic. So, and then here's just another picture of that discussion diamond that we did. And you can see that a lot of the students wrote quite a bit. And, each of them kind of came to the conclusion where it's like, it depends on the case, we need to keep everyone safe. They were really critically thinking about the concerns and the safeties of like humans and like whether we should use this tool. It was really interesting to see. And then once again, a picture of the dinosaur because they really liked the idea of like Jurassic Park was something that their mind kind of went to first. And so, like I said, they were kind of recognizing the complexity of the issue and they were thinking beyond just themselves. Like some students like put themselves in that situation, but they were mostly thinking about like others and like accessibility and like socioeconomic, like who's going to pay for it, or like political, like should this be regulated by the government? Like they were just thinking about all this great stuff. And most of this stuff that I didn't even mention in the like discussion lection portion of it, they kind of just like let their curiosity run wild, which was so exciting to see. Here are some quotes from the students. I felt like a scientist for the day. That was probably my favorite quote. Like I said, gene editing should be allowed if needed. We need to keep everyone safe. And then once again, it's like a case by case basis. Some student even mentioned like, oh, could this be used for like potential warfare and stuff like that, which is something I didn't even think of. So overall, through the experience of talking about like gene editing and using those tools, they were able to like develop their arguments, interact with each other, make personal connections, which showed that the students were engaged in all three dimensions and were actively applying their learning. So this is kind of like the post questionnaire. And we found that the lesson satisfied their curiosity. They found that it was useful and that a majority of them were engaged and like maintained focus the entire time. And then these graphs kind of show that they enjoyed acquiring new knowledge in the socio-scientific context, and that they envisioned themselves learning more about difficult issues in the future. So that was really exciting to see. And then real quick about the teacher experience, because, if we're going to implement, using ABE's resources or implementing SSI, it's really going to come down to the teacher and like how they're going to use it within their classroom. And she said, I'd like to incorporate a current event and issue into each of our major units. I got to see the students see the value and purpose of learning something novel and new. They loved the hands-on portion and asked great questions about the topic. So the teacher really loved this experience. Even though she didn't have a lot of previous knowledge about gene editing, she kind of relied on me to help kind of like guide the lesson. But she felt like she was learning alongside of her students, and she enjoyed the mixing of lab and reality. And she observed the students enjoying the material, actively participating with like little to no distractions. And then she displayed like a sense of excitement for the future of like, using SSI materials, using the ABE materials, potentially going to the professional development to be able to rent out the kits. And word started to spread within the school that I went to. So I am currently trying to plan going back to teach the rest of the 7th grade once I finish up with finals and all that. But yeah, she started to share to her colleagues and everybody else just like how great of an experience this was. But she did mention that in order to do this well, we do need those resources and the support. So really thankful for ABE for helping out with all of this. So kind of like to tie it all together. So SSI implementation and using those like biotech equipment gave these middle school students the chance to see all that science has to offer. They got to think, they got to explore, and they got to question the world around them. And with SSI, as we kind of went even through those 2 days, it's very flexible with how you can teach it and how you can like tie things together, because you're looking at 2 things, but they're blended into one. So, students were, working on their communication skills, their research skills, discussion skills, critical thinking, all of that great stuff. And then once again, it kind of showed that they maintained interest and that they were more engaged in like higher order thinking practices. And my main thing that I really liked about SSI was that it was student centered. The only time that the teacher and I really had to kind of like jump in was when they were using the materials. But once we kind of like got into it, they kind of just started helping each other, which was exciting to see. And with SSI, in order for it to be successful, you have to create like an encouraging and safe learning environment for them, and have the teacher kind of shift from being like an authoritative role to more of like a facilitator, especially with those like discussions. It's more fruitful, I think, and more personally engaging and meaningful if you kind of just let the students guide themselves. Because like the 3rd bullet says, the more students personally engage with content, the more they'll get out of it, which I stand by because I, saw it happen in the classroom. And then I believe that my involvement in this process kind of gave me a new outlook on SSI and basically teaching science in general, because I was able to actually be there and have those firsthand experience and observations. And as someone who didn't have any like prior teaching background, but I had that experience within the lab setting and about gene editing, that the students weren't concerned about getting the right answer, because there's not always going to be a right answer for complex issues like gene editing or like global warming. Like they're very complex and like dense that we can't always have a solution. So they weren't focused on that, and they weren't focused on getting a grade. That it just allowed them to focus on the content itself and focus on using the tools and focus on basically practicing being a scientist. And it was exciting to see. And also, I got the chance to share my knowledge, my stories, my successes and struggles with science and, being in college and doing all that. So I felt that also helped make it more relatable for the students. And so kind of getting into like future, what's next for SSI, this shows that we need to highlight new ideas and ways of teaching science education, and that we should look into more implementation of SSI or ABE, driven content within the classroom, because, we do those like extracurricular, after school programs, but it does work within the classroom. We just need more development and more resources for it to properly work. And we can also show that with these middle school students, I kind of went in with like a preconceived bias that they weren't going to be able to have these complex issues and like talk about controversial stuff, and that it was going to be very like surface level. But they proved me wrong. They were coming up with all sorts of like implications and just ideas about using gene editing and using tools and wanting to learn more about it, that I was honestly blown away. And that they were able to do that because of like the interactive learning environment that SSI like created, and also like the collaborative portion of it. And then also I kind of just realized that the center and the heart of education is the students, and that should be our focus. About, we want what's best for them so they can get the most out of what we teach them. And so, like I said, we want to create classrooms that are open and safe for them to explore and, just let their minds just go and wander, and then just kind of just like tie it all together for them, because they're constantly asking questions, like I said, about like, oh, how does this apply to the real world? Like all that stuff. And so if you kind of just like give them a little nudge, they'll go pretty far. And once again, science wants to create informed, responsible members of society to have like make informed decisions based on reliable information. And we can do that with science and with SSI. So overall, science is constantly evolving and changing with new research, just like CRISPR coming out, and new technologies. That the way we should teach science, we should be updating it using relative content to kind of guide it, so it's not just the same textbook that they've been using for 20 years, or the same like, you can have the same science content, but the way that you teach it, you can kind of like shift it and change it as the times shift and change. And so once again, you're going to equip these students to tackle these complex issues. So later on down the road, like me, so when you enter college and stuff, you're not scared to deal with those. You have that like previous experience to kind of like lean back on. And also, it was just exciting to see that these students had a new perspective and appreciation on science as a whole, and just they were engaging with it. They found it meaningful. I mean, I kind of ended the lesson one day on the second day, like, hey, do you guys imagine yourself doing this in the future? And so many of them were like, yeah, this is really cool. I kind of didn't want to do science, but now I'm more interested. They were like, yeah, I'm going to be a scientist one day. So, yeah. And so it showed that, it has increased participation and motivation and wanting to learn and discover more about science. And basically, at the end of the 2 days and after this whole process of my thesis, I showed these students that science can be fun after all, and that they're excited about it. And yeah, it was just so exciting to see it all. But yeah, and those are my references. So sorry, I kind of just took a long time to talk about all that, but yeah.
Yay!